Hello guys, so I'm changing the strategy this time and I'm going to upload a series of videos, probably 3 per lesson to make it easier for you. So it's going to be some chunks of probably between 5 and 7 minutes each, and hopefully that'll help you, I don't know, use these tools that I have for you to help you understand each of the sections of this chapter. And I'm gonna try to do it this way from now on. Okay, so I'm going to start talking about one of the concepts through an exercise in section 12.3. Okay, so what I'm going to do is explain a little bit about how to prove triangle congruence. It means if two triangles are congruent by one of the theorems that is labeled or known as SAS. That stands for segment angle segment or side angle side. Okay? So as I walk you through the exercise, you will understand what it means to prove when two triangles are congruent by this theorem. Okay? So the exercise we are given is the following. We have a pair of triangles that go this way. So this is the information we have, okay? We are given the vertices here. This is A, B, and C, and this is D, okay? And the information we are given is the following, okay? So we are told that B is the midpoint of the segment AC, okay? Also, we are given other piece of information. We are told that the angle ABC and angle, so it's angle ABC, it means this angle right here, and angle CBD are right angles, okay? And with this given information, and probably I'm going to label it like this, so these are givens, okay? So this is information we can count on. We know it for sure. With that information, then we have to prove that the triangles ABD and CBD are congruent, okay? So I'm going to walk you through the process, and again, remember, I want you to understand the grasp of that. When you get to SM2, we will do it in a more formal way, right? So we are going to do what we call a two-column proof. On one side of it, we have what we call a statement, and on the right of it, we're going to say what is the reason for what I am saying, okay? So for example, I can say the following. I can say that B, this point B, is a midpoint. And why can I say that? I can say that because it was part of the information I was given. So the reason why I can say that, it's because this is a given. And that is how I write it. Okay? With that information, I know that if B is the midpoint here, that means that this segment AB and BC are congruent. Something like this. I use these marks and I can say that. So because of this, because I know that the B is the midpoint here, I can say that segment AB is congruent to segment BC, right? So AB and BC are congruent. And why can I say that? I can say that because B is the midpoint. Okay? With this, I started indicating that there is one segment in the two triangles, okay, this segment and this segment, they are corresponding, they are also congruent, okay? Let's continue. We can also say this. From the given information, I say that angle ABC and angle CBD are right angles, okay? Why can I say that? It means this angle and this angle, they are right angles. It's part of the given, so this is the reason why I can say this, okay? Also, because of that, because this is right angle and this is a right angle, I can say that angle ABC is congruent to angle CBD, okay? And in this case, I am using something we call the right angle theorem. It's just part of the process, but I want you to see how the logical process goes as I solve this column here. When you check the quiz or when you check the homework assignment, you will see that you are guided through the process, which is what I want you to get familiar with, okay? So this is the right angle theorem, okay? And finally, I can say that, can you see that this triangle and this triangle share this segment BD? I can say that BD is congruent to BD. You know, it looks a little bit like, hey, it's confusing, but at the same time it's so logical because they share this same segment. And this we can say because of what we call the reflective property of congruence, okay? We'll deal more in more detail with reflections and all these transformations in chapter 11, but it's because I initially have this triangle here that can be now turned, turned this way, like this. Can you see? It's this way, and it can be turned this way, and we have the same thing, and it's because we are kind of having a kind of a hinge with BD. With that in mind, take a look. I just said that this segment and this segment are equal, congruent. So I am talking about one of the segments. I have also said that these two angles are congruent. So we're talking about angles, corresponding angles. And I am also saying that this segment right here, which are shared for both of the triangles, are congruent. Can you see that we are talking about segment, angle, segment? So I can say, as like the final conclusion of this proof, that the triangle ABD is congruent to triangle CBD. And why can I say that? Because I am using the side angle side theorem, okay, of triangle congruence. So the reason is SAS Congruence Theorem, all right? And with that, I am done with my proof, okay? That's all right? Take a look at it again. I started with one of the segments, then one of the angles, then the corresponding segment, but it goes side, angle, side, and the angle that I am proving to be congruent is the one that is in between the segments I want to prove as congruent. And then I'm done, okay? This is all.